Hi Year 11, our next topic is probability. And so the first page of your booklets is actually all this review from last year in terms of sets and probability that we did in Year 10. So you need to make sure you are okay with all of that. If not, going to your textbook, it does have more information. And with probability, we're going to be looking at experimental and theoretical. So just going to go through an example. So this first one, the colours of cars passing the school gate one morning is given by in this table. We want to estimate the probability that the next car to pass the school gates will be red. Then use that information if 150 cars were to pass the school gate the next day, and we want to estimate the number of red cars expected that morning. And then the colour of cars is also recorded the following day, and we have the results in that table. Now we want to have an improved estimate of the probability of the next car to pass the school gate being red. So the first thing we're going to do, we're going to estimate the probability that the next car to pass the school will be red. So we want the probability of the car being red, which if we look at this table, we have 26 red cars, so it's 26 out of our total, which is 110. Then we can simplify that down to 13 over 55, and if you want to write that as a decimal, it is approximately 0.236. With probability, you can leave your answer as a fraction, that's fine. Now part B wants us to use the information. So for the next day, if 150 cars were to pass, how many would be red? And so we just have to times 150 by our probability. And if we do that, we'll get approximately 35.5 cars, which obviously we can't have a decimal of a car, we can't have half a car. So you would more than likely round that up to 36 cars. Now C, we've got the next day, these cars were recorded, and now we want to have an improved estimate, so we want a better probability. So to do this, we need to add our red cars together. So it's going to be 26 plus 20, which is 46. And our total amount of cars is going to be 110 plus 92, which gives us 202. And so now the probability of a red car will be 46 out of 202, which as a simplified fraction is 23 over 101, or as a decimal, 0.228. All right, two-way tables. So we did do these last year as well. And this example, people exiting a new ride at the theme park were asked whether they liked or disliked the ride. The results are shown here. Use this table to estimate the probability that a random selected person who went on the ride, first liked the ride, is a child and disliked the ride, is an adult or disliked the ride. So the first thing that is always a good thing to do with two-way tables is to create some totals columns. And so what we normally do is we normally add a row and a column underneath the values. Sorry for my dodgy lines there. And we add them up. So 55 plus 17, 72, 28 plus 30, 58. We'll have 83, 47, and then you can add down or across, doesn't matter, but our total number of people was 130. So for part A, we want the probability that somebody liked the ride. So if we looked at liked the ride, it is here, and we look at our total for that, which is 83. So the probability that somebody liked a ride, so the probability that somebody liked the ride will be 83 out of 130. So B, we want the probability that they are a child and they disliked the ride. So if we want to look at child and disliked the ride, if we look at our two-way table there, you will see it will be the number 17 because it's child and disliked. So that will be the probability of child. And then we can use set notation if we like, because and is our intersection. So I'm just going to go child and disliked, which will equal 17 out of 130. Now part C is an adult or disliked the ride. So we need to look at all the adults and all the disliked, and we need to add them together. So it'll be 17 plus 28 plus 30, which is 75. Because it's an or, they don't have to do both. So we need to look at everybody in that row, in those rows and columns. And so then we have the probability of adult. And remember, the union is also or disliked. which will equal 75 out of 130. So a ticket is randomly selected from a basket containing 3 green, 4 yellow and 5 blue tickets. Determine the probability of getting a green ticket. So what we want to do here is just add up the total. So we've got 3 plus 4 plus 5, which will be 12 in total. And so a green ticket, so the probability of green will be 3 out of 12, which is 1 over 4. B, a green or yellow ticket. So they could get one or the other. So we need to have green or yellow, so which will be 3 plus 4. So the probability of green or yellow will be 3 plus 4 out of 12, which is 7 out of 12. C, an orange ticket. Now there are no orange tickets in there, so the probability of getting an orange ticket is just 0, because there are none. And the last one, a green, yellow or blue, which is all the tickets. So the probability of green or yellow or blue is going to be 1, because that's all we have in the bag. So if we pick a ticket out, we're going to get one of those 3 colours. And then quick Venn diagram example. So we have, in a class of 30 students, 19 study physics, 17 study chemistry and 15 study both. Put this information in a Venn diagram. So remember, in a Venn diagram, we need to draw our rectangle first. We have 2 circles for physics and chemistry. Our universal is 30, we have 30 in total. Now we have 50, we always start in the middle and work out. So 15 study both, so 15 will be in the middle. Now 19 study physics. Now we've got to remember that has to include the 15, because that is also part of physics, which means there's 4 that study only physics. Now 17 study chemistry, which means that whole circle of chemistry once again needs to add to 17. We already have 15 in that chemistry circle, so we need 2 more. Then for the outside, we need to work out how many are left over. So we've got 15 plus 4 plus 2, which is 21, which means there's 9 people that don't do physics or chemistry. And then part B, we're going to find some probabilities. So the first one is they do both subjects. So we want the probability of physics and chemistry, which is the intersection in the middle, which will be 15 out of 30. Number 2, studies at least one of the subjects. So at least one of the subjects means they could do both, they could do physics or they could do chemistry. So it is going to be all the circles in the middle, which adds up to 21. So writing this in notation, it's going to be the probability of physics or chemistry, which will be 21 out of 30, which is 7 over 10. Number 3, physics but not chemistry. So to write this in notation, we want physics and not chemistry. So not chemistry, write the C and the dash. Now physics but not chemistry will just be the 4, because that 15 in the middle studies chemistry. So it's only going to be 4 out of 30. Or we want exactly one of the subjects. So exactly one of the subjects means they can study physics or chemistry, but they can't do both, which will be the 4 and the 2. So the 4 that do only physics, the 4 and the 2 that do only chemistry. This in notation, it's a bit harder and long-winded. So what I'm just going to do to just save some space and do it quickly, I'm just going to do, I'll just write this in words, which you can do as well. So studies exactly 1, which would be 6. So it'll be the 4 plus 2 out of 30, which is 6 out of 30, which we can simplify down to 1 out of 5. And the last one studies neither, so that is the outside. And we can write that as not P and not C, which will be 9 out of 30. And that's it for Venn diagrams, and that's it just for a quick review on probability that we've done previously.